Hey guys, so expressions unit here. All right. Notes should be taken care of. It's your unit number 3. All right. Um, Lesson number 3 as well. I notice NFL referees do this for third down. Basketball referees do this for the 3 point. So yeah, I just anyway. So yeah, lesson 3. Let's look at some entrance slip problems here, people. So let's see here. I've got them right down there. There we go. There we go. Hey, entrance slips, unit 3. All right. We go in a little bit of a different order there. There's our expressions. We're going to start with lesson number 3 here. And this is actually one of our properties. We really didn't spend a lot of time with it. Might have talked about it, and that was about it. But it's your distributive property. And in your distributive property, it's kind of like what it says, you're distributing, which means to hand out. All right. We'll kind of show you what we're doing here. So the idea behind it is we know a number up against parentheses means multiply. But when you go inside those parentheses, there's not one person there. All right. We actually have 2 people that are there. So it's the Halloween problem. Doorbell rings. All right. Kids come to the door, trick or treat. I don't go, wow, hey, you're the first one. You get candy. Bye bye, everyone. Sorry, nothing for you. No, everyone that shows up the door. All right. You go ahead and drop a little candy in their bag there. So, same thing going on here. A number of constituents multiply, but you got to make sure that you multiply to everyone that's inside the parentheses. So when we do this, 4 times 2x is 8x, and then 4 times 9, that's a 36. So 8x plus 36. That's it. All right. This is what we call simplifying expressions. We're going to do all these little pieces of things and then start really tying everything together. So again, question number 2, a number up against parentheses multiply, but there are 2 people that are inside there, so I got to multiply the both people. So negative 5 times 4x, negative 20x. Now keep in mind here, that is 5 is negative. Look at that 2. That 2 is also negative. So a negative 5 times a negative 2, yeah, positive 10. There's something that we're going to get into shortly here called like terms. Like terms are, excuse me, like terms are people that we can add together. So it's kind of like combining things. Like if I have 2 pennies over here and I have 3 pennies over here, I've got 5 pennies. But if I've got 2 pennies over here and then I've got 5 quarters over here, I don't have 7, you know, well, I don't know what happens when you combine quarters and pennies. Qu- Quinnies? I don't know. You can't do it. All right, they're separate. You can't actually combine them together and make one particular thing. So we have to leave them separate. We can't actually add them together. Okay, so in question number 3, there's a few different approaches here, and so we do want to kind of show you the different varieties there. First of all, the parentheses. Okay, one of the things we've talked about is we typically don't see that division symbol. We use that fraction bar. And because all of this is inside parentheses, that tells me all of it is up in the numerator that's there. So what we've got to keep in mind here is that when we're doing our division, we have to divide to everyone who's up there. Excuse me. So if I take this negative 25x and divide by 5, well, negative 25 divided by 5 is a negative 5. A negative 5 divided by a negative 5 is a positive 1. So there's my winning answer. Now, a little foreign there, all right? The other thing to keep in mind here is this dividing by 5. Dividing by 5 is the exact same as multiplying by, yeah, 1/5. So it's actually one of these guys in disguise. It's really taking 1/5 and multiplying it by negative 25x. It's 5. And if you take a fifth of a negative 25, you get negative 5. So there's your negative 5x. You take a fifth of 5, there's your 1. All right. And, ooh, Oh, -5. You probably caught it, but you didn't. Yeah, I know. Oh, there you are saying it now. Okay, all right. Sorry, it shouldn't be a plus sign there, right? Because that's a, a -5 divided by 5. Yeah, so that's a -1 there. All right, there you go. There you go. All right. So notice our answers will match up. Again, a fifth of -25, -5. So there's your -5x. A fifth of -5 is your -1. So there we go. So what we can do here is we can rewrite it as a fraction, or you can rewrite it using your distributive property. So again, dividing by 2 is the same as multiplying by a half. All right. So we can see our distributive property in action. Half of -22, all right, -11. So it's -11a. Half of 4b, all right, so half of 4 is 2. All right, so it's your 2b that's there. Again, the other way you could do it here is rewrite it as a fraction, because again, when we divide by 2, all right, so 4, 2, all of that's wrapped in parentheses, which means all of that is upstairs. The only thing we've got to keep in mind is, my goodness, that's not right. No, it's not. We got to keep in mind here is that you have to divide that to everyone that's involved with it. All right. Look at all that space I've got. All right. Yeah. So -22a plus 4b, all of it being divided by 2. And again, -22 divided by 2. So again, it's the idea of multiplying by the reciprocal is the exact same thing as dividing. So take that as to whatever one makes you feel more comfortable. Do you like rewriting as distributive property? Do you like rewriting as a fraction? Maybe it's just what you feel like on that particular problem. So, okay, let's go on classwork. I do want to show you a little bit into your classwork here. Let me bring up the packet that's here just so you can see. Again, pause the video if necessary. Um, what they're doing here is they're bringing out some elementary school ideas, the rectangular arrays, all right? And what they're working off of is the whole area thing. To find the area of a rectangle, all right? Find the area of a rectangle. We do multiply the length and width together. So that's what they're asking you in a way to kind of do here. So write two equivalent expressions. Well, 3 times 2a, 6a. All right. 3 times 5 is a 15. So we would add them together, but we really can't because we don't know what the A is. Think of it like an order of operations problem. You have to multiply first before you can add, but you know what to multiply by? So you just can't be like, let's just skip it and we'll just add them together. Yeah, no, 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 no. You're like, listen, I see the addition there, but I can't do it yet because I haven't multiplied yet. I'm sorry, we gotta wait. We gotta wait. And so that's why we leave that alone. The other way of looking at it here is you are multiplying 3 times that 2a plus 5. So there's your kind of two equivalent expressions. In other words, I want you to see two different ways. I'm not as worried about that. Your rectangular arrays kind of go bye-bye when it comes down to it. This question number 2 is a phenomenal question because it's what we're going to be getting ourselves into. You can skip B, that's there. It's one where we're going to be doing a lot more of this. They kind of give you a sneak peek at it there. So it says you and your friend made up a basketball shooting game. Every shot made from the free throw line is worth 3 points. And every shot made from the half court mark is worth 6 points. Write an equation. And again, that's the stuff we're going to start doing here soon. That represents the total amount of points. And they want you to use letter P for it. If F represents the number of shots made from the free throw line, and H represents the number of shots made from the half court line. Explain the equation in words. Okay. We can hold off on the explanation in words because I'm going to end up talking about this with you here. So this is something that we like because it gets us to write mathematically here. So write an equation that represents the total amount of points. Okay, total means what? Total means, yeah, we're going to add things. So the idea here is we are going to add two things together. All right. We're going to add, oh my goodness. I knew I should have been patient there. We're going to add two things together. And it's going to equal the total amount of points. Well, this is where we start putting things into place here. Okay, well, what do they want me to use for the total points? Oh, you want to call it P. Okay, so we're going to call it P there. And then the two things we're adding together are your free throws. So the two things that go into making up the points are our free throws and our half courts. So they're telling you the F for the free throws. But wait, how much is a free throw shot worth? It's worth how many points? Yeah, free throw is worth 3, they're saying. So it's 3F. And then we have to add it on to the half court shots. But wait, how much is the half court worth there? Yeah, 6. Yeah. So yeah, we like this. And again, here's your explaining in words. If we make 5 from the free throw line, how many points would that be? Well, we would do 5 times 3 to get 15. If we make 2 from the half court line, well, that would be 6 times 2 is 12. How would you get the total points? Well, we would add the two together. So again, this is what we're going to be getting to. We're not there yet, but that's the kind of stuff we'll be dealing with. I'm not worried about the rectangular arrays. All right, as we kind of talked about, we kind of took care of it there. I'm fine with that. I'm just going to have you jump into the second page that's there. So you can skip those other ones. And again, here we are, use the distributive property to write the products as sums, which pretty much just means, hey, don't forget, you've got to make sure you multiply to everyone. So 3 times 2x is 6x, 3 times -1 is a -3. Don't forget also, when it's your division one, again, you can rewrite it as a fraction if you would like. All right, divide it by 10. You just got to make sure you divide everyone by the 10 there. Or you can see it as multiplying by the reciprocal, and it is the distributive property as well. So again, completely up to you how you want to go about those division ones. As we go further down the road here, all right, we can see more of them there. The bottom ones you can hold off on. All right, when I say bottom ones, I mean as in these guys. So we can hit the brakes right there. Okay, don't cross them out. They're good problems. We're going to get to them. But you know, so really what we're focusing on are those groups of problems we're dealing with. As I stare at letter F here, all right, remember your commutative property, 2 times 3 is the same as 3 times 2. So for letter F there, yes, that is the exact same thing as if it was out in front. That's an L that's there, by the way, all right? So we can see that. This guy's a good one, dividing by half. All right, we'll let you play with that one there. I'll get answer keys. They'll be posted up for you here shortly. So you can certainly go find those guys as well. So, all right, guys, that's what we got for you today. Enjoy.